Okay, so a light beam. Suppose the function y equals 5 tangent pi over 4t marks the distance in the movement of a light beam from the top of a police car across a wall where t is the time in seconds and y is the distance in feet from a point on the wall directly across from the police car. So you have this police car, something like that, and on top is this light coming off, right? And it's hitting some wall, okay? So something like that. But on the wall, there's a spot right across from the police car. So here's the police car with the light coming off, you know. And then that light is moving. The beam of light is moving. I'm thinking that it's one of those lights that goes around, right? Like that, okay? All right. So we can talk about the stretch factor of 5. So stretch factor 5. Let's talk about the period as well. So the period is going to be pi over 4, which is equal to 4. Okay. Now let's get a graph. We have to graph it from this for this interval, 0 to 5. So we don't have a phase shift. We don't have a vertical shift. So let's think a little bit about the tangent curve because it is tangent. So if our period is 4, we want to go out 2 and -2, right, to get the 1 period. Now, you know, I'm not really going to have a negative amount of time, but that's going to help me get my bearings for the curve. Where would the next asymptote be? Well, you've got to go a period of 4, right? So we'll mark off 4, and then, yeah, okay, 4. Oh, I meant 6. Okay. Well, we'll count by 4. 6. 6 would be the next asymptote. Like that, okay? And we're going to stop here in our graph at 5. Okay, now, the other thing we have to consider is that it's going up 5 feet or down -5. Okay, now, think about the curve then, how we draw a tangent curve. We're starting at 0, so 0, 0, right? And then halfway between 0 and 2, so right here at 1, it's going to be up here at 5. So what that means then is, here you are at 0, 0, 0, say, the light beam is right across from the police car. After 1 second, it's moved over here 5 feet, okay? So the distance now is 5 feet. I'm assuming that the light beam is going, around horizontally. It's not moving up and down. Okay. So that's that part of the curve. Yeah. Okay. Then the next place where it's going to be 0 is going to be at 4. Okay. So, after 2 seconds, it's going off the wall, right? You're not going to see it until we get back here, when it's coming back. We can graph this. Oops. Here at 3, we're going to be down at -5. So down here. And then at 5, where will we be? Well, we're going to be back 5 feet away. So it's going to go like this. So here we're to the left 5 feet when, it comes back on the wall. And so at 3 seconds, it's coming in 5 feet away on the left side. Then it's coming toward right across. At 4 seconds, it will have made 1 complete revolution, the light beam. And then at 5 seconds, it's going to end, at 5 feet away. Okay? Now, you don't really need, let's see, let me erase this. Oh, well, we needed some of that. Okay. We're stopping here because it says to graph from 0 to 5. Okay, so that's for 5 seconds. You know, that's what's happening. It starts, the light beam starts across from the police car, moves 5 feet, and then eventually it's going off the wall. It's coming back on this side, negative 5 feet away, and then it's made a full revolution after 4 seconds. And then if it goes one more second, it's going to be 5 feet away from the wall, and then, you know, it keeps circling around that. All right, so that was part A and part B. Evaluate f of 1. Well, you can do this. You could plug in f of 1 equals 5 tangent pi over 4 times 1. You don't really have to do that because you could read it off the graph, right? But it's not a bad idea to double check. So 5 tangent pi over 4. But we know the tangent of pi over 4, it's 1. So 5 times 1, which is 5. So discuss the function's value at that input. So at 1 second, after 1 second, the light beam is 5 feet from the spot directly across from the police car. Have to scroll it up to write that. Spot directly across from the police car. Okay. And that's what it means. Okay.